Okay, example 4 on set 9.3. Solve x plus 3 squared plus y minus 4 squared equals 20, and x plus 4 squared plus y minus 3 squared equals 26. What we have here is two circles at different centers with different radii in standard form. And in their current form, I would not want to solve this. It just kind of looks a little unfriendly. So the first thing I would personally do on this problem is I would just square everything out and get everything to general form. So I'm going to get for this, it's going to be x squared plus 6x plus 9. This is going to be y squared minus 8y plus 16. I'm going to move the 20 to the other side, so minus 20, and that's going to equal 0. So get myself to general form. So if I go ahead and combine like terms, that whole equation becomes x squared plus y squared plus 6x minus 8y, 25 minus 20, so plus 5 equals 0. Then I'm going to do the same thing to the second equation. X plus 4 squared becomes x squared plus 8x plus 16. And y minus 3 squared becomes plus y squared minus 6y plus 9. And the 26 I'm going to move to the other side, so minus 26 equals 0. And that whole thing, if I simplify it, becomes x squared plus y squared plus 8x minus 6y. 25 minus 26 is minus 1 equals 0. That's going to be my starting point. I think the next thing I'm going to want to do is this. I'm going to change all the signs in one of the equations in order to get rid of the squared stuff. I'm going to go minus, 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 plus, plus. Add them up, see what happens. So 6x minus 8x is negative 2x. Negative 8y minus 6y is negative 2y. And 5 plus 1 is plus 6 equals 0. And I'm going to divide everything by 2. I'm negative 2 actually. Let's go negative 2. So x plus y minus 3 equals 0. Just get my variables positive. And if I go ahead and move, let's say, the y minus 3 over, so x equals 3 minus y. Or y equals 3 minus x. Take your pick, doesn't matter. Either one's just as easy. They're both a coefficient of 1. No division necessary. What I want to do is I want to take this expression here back into one of these two equations up here, getting myself down to just a simple x or simple y equation. So if I change all the x's, I'm going to go into this equation here into 3 minus y. So it becomes parentheses 3 minus y, the quantity squared, plus y squared, plus 6 times the quantity 3 minus y, minus 8y, plus 5 equals 0. And now I just got this big quadratic y equation. I want to simplify this as much as possible, get myself down to quadratic equation form, do some factoring, all that good stuff. So 3 minus y squared is 9 minus 6y plus y squared plus the other y squared plus 18 minus 6y minus 8y plus 5 equals 0. Altogether I've got 2y squareds. I got minus 6y, minus 6y, minus 8y is a total of minus 20y. And I've got 9 plus 18 plus 5, which is 32. Everything's even, so I divide by 2. Y squared minus 10y plus 16 equals 0. Factoring y minus 2 times y minus 8 equals 0. So y has to equal 2 or 8. Wants to know what y equals. X equals 3 minus y, so for each y I got to find an x. So for y equals 2, x is going to equal 3 minus 2, which equals 1. So my ordered pair is x1, y2. For y equals 8, x should equal 3 minus 8, so x equals negative 5. So negative 5, comma 8. Alright. there are going to be some problems just like that. So that's the basic technique. You're going to get the same structure here, so eliminating the squares out to get just to linear terms, to do a real simple substitution into one of these expressions is the easiest way to go about doing it. There might be some other techniques that work also, but to my knowledge, that's probably the most efficient, so I go that route.